Welcome to SPC Insights with Dr. Bill, simplifying SPC and statistical analysis. Today we're going to look at the impact of out-of-control points on baseline control limits. So in this video, we're going to view control charts. We're going to talk about how they separate the signals from the noise in the process. We're going to take a look at two baseline data examples, one in control, one out of control, and then answer the questions: do you plot the out-of-control points, and do you include the out-of-control points in the calculations, and also a word of caution. So let's review control charts. Control chart monitors process variation over time. You plot data over time. It's going to separate special causes of variation from common causes. Common causes is the noise in the process. It's the natural variation that variation exists in your process. Take into how long it takes you to get to work each day. Doesn't take you the same amount of time each day, but over time there's a range that is normal for you. Maybe that's 25 to 35 minutes. And this normal range is what we call common causes of variation, the noise in the process. Now, sometimes you have a special cause of variation present. It's not supposed to be there. It's a signal. Something in your process has changed. For example, if you're driving to work and you get a flat tire, the odds are you're not going to make it in the normal 25 to 35 minutes. That's a special cause of variation. It's not part of the process. It's not supposed to be there. So it's going to take you longer than 25 to 35 minutes, and it's going to signal it very well in the control chart. So you're going to separate special causes from common causes by using the control charts. 5 simple steps. 1, you gather your data to start with. So here we have collecting our data on maybe the time it takes us to drive to work. We first sample is 28.7 minutes. Going on down till we get 20 data points. And then after we have that data points, we're going to go ahead and plot the data. Now, you don't need to have 20 data points before you start. You can start a control chart with as few as 5 data points. You just simply recalculate the average and control limits till you get up to 20. So here on day 20, we had that flat tire, and you can see that that's up above the normal range. Then you calculate the average and plot it on the chart. Our average here is almost 31 minutes. Then you're going to calculate the 2 control limits and add them. The upper control limit's the largest value you would expect if you just have common causes of variation, and that's about 41 minutes here. And the lower control limit, or LC, is the lowest value you would expect if you just have common causes of variation. It's about 21 minutes here. Then you interpret the chart. As long as you have no points beyond the control limits or patterns, you're in control. We have 1 point above that upper control limit. We turn it red. That's an out of control point. So let's take a look at baseline data. We're going to use the individual's chart for this. It's 2 charts, the X chart and the moving range chart. We're going to do one that's in control, and we're going to do one that's out of control. And our objective here is to determine the control limits to judge performance in the future against. So let's start now with our in control baseline data example. Here we have our process that's in control. We've plotted it. We have 25 points in this case. Nothing's beyond the control limits, no pattern. This process is in control. We can extend those limits into the future and judge performance against that. Same thing here with the moving range chart with the individuals, where you're plotting the range between consecutive samples. It is in control as well, and you can extend those limits. Now here's one, though, that we're having out of control baseline data example. We have 2 points that are out of control. It's going to impact the average and control limits. Average here is 48.8, but it's higher because we have those 2 out of control points. They're the equations if you're interested. And we also, on the moving range chart, take a look at it, and we see we have 3 out of control points there. And that's going to increase that average range up to 9.0. And here are the control limits for the range chart that you can look at. Now, the interesting thing is the average range is used on the X chart. So that's inflating the range or control limits on the X chart. So how do you handle the out of control points? Do you ignore them? No. At a minimum, you should plot the out of control points on the chart. Always plot all your data. It's part of the history of your control chart. But do I include the out of control points in the calculations? That's a very good question, because with your moving range chart was out of control, you had a higher average range that increases the control limits on the X chart. So what do? You include all of them, include some of them, or include none of them. So here's our rule of thumb. If 10% or less of the points in the baseline data are out of control, take them out of the calculations, extend those into the future. If they're more than 10%, include them all in the points in the calculation. You're not in control, and here's your word of caution. You don't need tighter control limits that could well overwhelm you without a control points. So here's our first removal. Here's the out of control points. X chart, we have 2 of them. It's less than 10%. We're going to remove those from the calculations. We have done that there, and you see they've changed the red to being clear. That means they're not included in the calculation, and we can see our average has dropped down to 46.1. But we now have a new out of control point in the process. And here's the out of control points on the moving range chart that we took a look at. This is now removing those. And you can see we reduced now the average range down to 4.6, but we have two new out of control points as well. So we're going to do the process again. We're going to take it and we're going to remove the control limits again. So this is the 0.20 that's below it. We remove it. And you can see now that we have three out of control points that we're not considering in the X chart. And we do the same thing with the moving range chart. We remove the two that are out of control for subgroup samples 20 and 21, and you can see our average range has dropped down to 3.2 again. And now we can take these limits, put them into the future to judge performance. So what's happened? We had our original, which had an average of 48.8. We removed out of control points twice. It changed the average to 46.8. But here's the big thing. Look what happened on the moving range chart. Average range went from 9 to 4.6 to 3.2, about a 2/3 reduction in it. So in summary, if 10% or less of the points of the baseline data are out of control, remove them from the calculations. If it's more than 10, keep them in the calculations. But use your knowledge of your process to determine if that 10% makes sense for you. Thank you for watching our SPC Insights video with Dr. Bill. Click on the YouTube subscribe button. You can visit our SPC Knowledge Base for over 220 articles, all free, or you can make your own control charts with our software. We do have an article on the SPC Knowledge Base dealing just with this topic. Thank you for watching the video.